Hello, welcome to Solve Tree. In today's lesson, we are going to solve an exam question which relates to the laws of indices. And this is the question we are going to solve. We are given 5 raised to power 3n minus 5 raised to power 3n minus 1, then divided by 5 raised to power 3n plus 1. And for you to be able to solve this question, you need to remember two laws of indices, the product rule and the quotient rule. And to remind you the two laws, let's say for the product rule, let's assume you have a stem base which is raised to power m, then again multiplied by a, which is still the same base, raised to power n. This is the same as writing a, which is the same base, raised to power m plus n, meaning if we have two bases which are the same but raised to two different powers, you can just take the base, then you add the powers. And then the question rule says, if we have, let's say, still a raised to power m divided by a raised to power n, we can write it as a, which is the same power, the same base, raised to power m minus n, like that. Meaning, if we have bases which are the same but they are raised to different powers, then they are divided. We can just take the base, which is the same, then we subtract the powers. Now, with this knowledge of the two laws of indices, we can be able to solve this question here. And we can start with the first part, which it says 5 raised to power 3n. That one has no problem because it doesn't apply any of these laws. It's just a base raised to a certain power. But the second part here, which is 5 3n minus 1, it looks like it is applying this second law here, which says a raised to power m divided by a raised to power n is the same as a m minus n. So you see, they gave us this side here, so we need to work it backwards and get this side. So let me put this 5 raised to power 3 n minus 1 to this side, and then I say is equals to, you see, we said a raised to power m can be written now. In our case, m would be 3n, so it would be something like 5 raised to power 3n, but now divided by 5, which is the same base, raised to power 1, n now becomes 1. So this is, we have written this one in terms of this law. So now, finally, we do have this 5 raised to power 3n, then divided by, I can just divide it like this, 5 raised to power 1, and 5 raised to power 1 is just 5. So now it becomes 5 raised to power 3n divided by 5, which is the same as 5 raised to power 3n multiplied by 1 over 5, like that. And we are done with this first part here. But you see, we also had our 5 raised to power 3n. But before we go, we combine them, which is now will form the numerator. We can try to sort out the denominator, where we have 5 raised to power 3n plus 1. And if you check well the product rule, it's kind of like here, they have given us this side where 3n now is the m and then 1 is the n. And then here, of course, 5 is the base, is a. So if we have 5 raised to power 3 n plus 1 like that, then it will mean it's the same as 5 raised to power 3n, where now 3n is our m here, then multiplied by 5, but now raised to power 1, where hen 1 is our hen here. So now that we have this, we can now combine all of them. So we'll start with the numerator, where we have now our original 5 raised to power 3 n, 5 raised to power 3 n, minus, we got this 5 raised to power 3 n, then multiplied by 1 over 5, like that, 1 over 5. But you see, 1 over 5, 5 raised to power 3 n and 5 raised to power 3 n are common, so I can factor them out and say it's just like 5 raised to power 3 n into 1 minus 1 over 5, like that. Then from there, we can divide it by, we already got our denominator, which was 5 raised to power 3 n, then multiplied by 5 raised to power 1. But you see, 5 raised to power 1 is just 5, so we can just say it's 5, like that. And now you see this 5 raised to power 3 n and this 5 raised to power 3 n are just common on both sides, so we can cancel them like this. And now we remain with 1 minus 1 over 5, then divided by 5. So can we try to solve that? So if we start with the numerator, 1 minus 1 over 5, this 1, I can just write it like 5 over 5, because 5 over 5 is the same as 1 over 1, and 1 over 1 is just the same as 1. Then I subtract 1 over 5, like that. Then all of these I divide by 5. This 5 here. So from this one, I can say 5 over 5 minus 1 over 5, because the denominators are the same. I can just take subtract the numerators direct. So I take 5 minus 1, which is 4, then all over the denominator, which is 5. So on the numerator side, I have 4 over 5. Then on the denominator side, I have 5. So now it becomes 4 over 5 and divided by, I can now use the normal division, divided by 5, this 5 here, which is the same as 4 over 5 multiplied by 1 over 5. So that I changed the sign to multiplication, then I took the reciprocal of this 5, which now the answer becomes 4 multiplied by 1, which is 4, then divided by 5, multiplied by 5, which is 25. And that's how we solve that question applying the laws of indices.